Hello everyone. In the last class we studied about hydrogen spectrum, right? In this class we will discuss about Sommerfeld's atomic model. This model of atom is just a development modification of Bohr's atomic model, right? So the basic advantages of this model is that a subshell is inside a cell. Means we knew from quantum numbers, just we studied in the first year or class 11th, that some subshells make a cell, or a cell is made up of subshells, right? So in this particular model we will be introduced about that subshells, how they are present inside a cell. So what are the postulates of Sommerfeld's model? Okay, so the first postulate is that when electron moves around the nucleus, the path of the electron is influenced by the nucleus. Thus, it gets an elliptical path instead of a circular path, right? So, the path of the electron is influenced by the positively charged heavy nucleus. Thus, an electron take an elliptical path. That means from Bohr's atomic model we knew that electrons move around the nucleus in circular path, circular orbit. Here we say orbit can be elliptical also, right? So that is due to the influence of the nucleus on the path of the electron. So we can write here that the path of the electron is like this, an ellipse. Okay, this is the point 1. 2. Second point is, while moving around the nucleus, an electron takes an elliptical path, but where the nucleus will present? The nucleus will be present at one of the foci of the nucleus. Okay, so the nucleus remains present at one of the foci. Foci means, as you know, if this is the nucleus, an elliptical path, an ellipse, if this is the orbit of the electron, path of the electron, then there should be two focus, right? Two foci. That means here or here. Out of two foci, at one foci, one of the focus, the nucleus will be present, right? So this is the nucleus that is present at one of the foci. Okay, and this is the path of the electron, elliptical path. Okay, so next point is, once we knew about the elliptical path, from there we can have two quantum numbers. This elliptical path has two axes. Every ellipse has two axes. One is major axis and another is minor axis. This major axis and minor axis will be linked through two quantum numbers. They are principal quantum number and one azimuthal quantum number. And as we know, azimuthal quantum number introduces us about a subshell, right? So the third postulate should be the elliptical path of an electron are quantized. What is quantized? Means a fixed energy quantized, like we calculated the energy for an electron for any single electron species in case of Bohr's atomic model. So the elliptical path of an electron are quantized with respect to their energy. The formula of the electron En is equal to minus k z square into 1 by n plus k, 1 by n plus k. 1 by n plus k, let us give the square here, 1 by n plus k square. So you are now being introduced by two quantum numbers, one is n, one is k. So where n is the principal quantum number, and as we know, principal quantum number gives idea about cells, and the second quantum number k is the azimuthal quantum number that gives us idea about subshells. Okay, so from this, how these two quantum numbers, how these two numbers are interrelated. This n and k are linked through the major and minor axis. So n by k is equal to length of major axis by length of minor axis. Which one is the major axis and which one is the minor axis? So if this is the elliptical path and the electron will present at one of the foci, this is called the major axis and this one is the minor axis. This is the minor axis. And now it is clear that as you change this major axis and minor axis, you can get different elliptical orbits for an electron. Okay, so we will take an example with principal quantum number is equal to 4, n is equal to 4, and how this azimuthal quantum number changes, and accordingly how we get different elliptical path in the same orbit, and we will see how different subshells are present in a cell. Okay, so you see, for example, we will take n is equal to 4. For each value of for each value of n, the value of k is equal to 0. K is equal to 1 to n. Okay. So we are going to represent how n and k are interrelated. So n is equal to 4, and for each value of n we have taken n is equal to 4. K will have value 1 to n, means here n is equal to 4. So implies K is equal to 1, 2, 3 and 4. So 4 values of K for n is equal to 4. And how we 4 value of K means 4 subcells in the cell number 4. We'll see by the diagram. See, first one, say this is the nucleus, and another elliptical path is like this, another elliptical path like this, and this is and this is the 4K value. We have taken n is equal to 4, for which K will have 4 values 1, 2, 3, 4. This is having n is equal to 4 and K is equal to 1. This next one, n is equal to 4, K is equal to 2. Then next one, n is equal to 4, K is equal to 3. And this is simply a spherical orbital. So this is n is equal to 4, means circular orbital, n is equal to 4 and K also is equal to 4. And when both the azimuthal quantum number and principal quantum number becomes equal, they give a circular orbital, right? So it's you should have a note like this: when n is equal to K, this implies a circular orbital. Did you get me? This means a circular orbital. So that means you are getting 4 subcells in the cell numbered 4. So 4 subcells in cell n is equal to 4, means KLM cell. For n is equal to 1 in Bohr's atomic model we have studied. For n is equal to 1, that is K cell. For n is equal to 2, that is L. N is equal to 3, M. N is equal to 4, N cell. So n cell contains 4 subcells. One of them is elliptical according to Sommerfeld. One of them is circular. All other 3 are elliptical, having various azimuthal quantum number. Do you get me? Okay. Then we'll see how for certain atom we can represent this represent an atom and their electrons, positions of electrons inside cells and soft cells in an atom. For example, we will take the example of neon. Okay. Now see, we will take the example of neon. Its atomic number is 10. Its electronic configuration, as you know, 1s2, 2s2, 2p6. This 2p is divided into 3 orbitals: 2px2, 2py2 and 2pz2. Okay, so this is an orbital, this is an orbital, these 3 are orbitals. So we have to show how n and k will be interrelated in this neon case. So you see, so this is the nucleus. This is the nucleus. First 1s means this is circular, then 2s, this is also circular, both of them contains 2 electrons moving around the nucleus, and another is now another 3, this is subshell 2p should contain 6 electrons, but how? By elliptical path, this along this direction, this along this direction, and this along this direction. This contains 2 electrons, this also contains 2 electrons, this elliptical path also contains 2 electrons. So in total 6 electrons in the 2p subshell, and in total 2, 2 and 6, 10 electrons are present like this, right? So now we will move to the position of electron, how the position of an electron in an elliptical path is assigned, right? So you see, next postulate is the position of electron is determined by radial distance, by a radial distance, that is called r, and an azimuthal angle, and an azimuthal angle phi. Okay, so these two things will ascertain you about the position of electron in an elliptical path. How? You see, this say is the nucleus that should be present at one of the foci. So this is the elliptical path. Okay, so say the electron is present here. What is the position of electron in this elliptical path? So this is the center of the nucleus, this is the radial distance r. So this is the major axis. The angle between the major axis and the radial distance is called the phi, means azimuthal angle. When you know the angle made by the variable distance r, and that variable distance r, what is the angle made by this variable distance and the major axis, phi, then by using r and phi you can determine the position of an electron in an elliptical path. This is very important point of Sommerfeld's. Okay, so these are some of the basic postulates and concept of Sommerfeld's model. So next we will move to what are the disadvantages of Sommerfeld's model. Okay, these are the disadvantages. The first one is Zeeman and Stark effect. Like Bohr's atomic model could not explain the Zeeman and Stark effect. Very fine line, then fine line, then still fine line, very thin fine line made by Zeeman and Stark effect related to orbitals. Why these very fine lines are obtained in the spectrum, that could not be explained by Sommerfeld also. Bohr could not explain, Sommerfeld also could not explain the very fine line in the spectrum. The Zeeman and Stark effect, Zeeman and Simply Zeeman effect. The Zeeman effect could not be explained. Could not be explained. Second thing, as you know from quantum numbers, the value of azimuthal quantum number for any value of n, means for any principal quantum number, the azimuthal quantum number values should be what? Should be 0 to n minus 1. We know this, but Sommerfeld suggested, what did he suggest? He suggested that k is equal to 1 to n. This is faulty. So like this, there are some other theoretical value and practical value were not matching in some calculations. So these are some basic concept of Sommerfeld's model. In the next class, we will not study this atomic structure. In the next class for your BSc, we will study about physical chemistry, the gaseous state, and the kinetic theory of gas, and we will derive the equation PV is equal to 1 by 3 mn c square. Thank you so much. We will discuss in the next class.